So we took derivatives of vector functions. Let's take integrals of them. Okay, the indefinite integral of the vector function that you see here is given by the vector function that you see here plus c. Now, how did we get that vector function? Well, f of t is the antiderivative of lowercase f. Okay, so f prime will give you f, g prime will give you g, and h prime will give you lowercase h. Okay, and so basically how you want to think about this is that in much the same way that all you did was take when you took a derivative of a vector function, that you just moved the derivative into each component. Well, you're doing the exact same thing here. Okay, you're taking the indefinite integrals of each of these functions, but don't forget the constant. The constant's very important. Okay, so let's take a look at an example. We want to find some r of t, okay, where its derivative is equal to this, and it has a value at t equals 0 equal to this latter part, okay? Well, if the derivative is equal to this, here's the strategy. Let's take the antiderivative of the derivative so that we get some r of t, and then we'll match the condition r of 0 equal to this using our constant. Let's see how that works. So the first step, we have our derivative here. We're going to integrate. So we're going to take the integral of a derivative, which returns back the original function, right? So here's the integral of this vector function, which again is actually the derivative of r. So integrating, we just move the integral into each of the components. So now the integral of e to the power t is just et. What's the integral of cosine t? Well, that's going to be sine t. And what's the integral of 2t? That's going to be t squared. Okay? So just like that, we take the antiderivative, but don't forget this is the indefinite integral, so we also have a constant. Okay? So that's the indefinite integral part. What about making sure that this r satisfies this condition there, that at t equals 0 equals to this vector? Well, this left-hand side here that you see circled is the given condition. Okay? So that's the condition that we want to match. This right-hand side is what I get when I plug t equals 0 into my antiderivative. So plug in t equals 0 into here, you'll get e to the power 0, sine 0, 0 squared. So I hope you understand that where the right-hand side and left-hand side came. That's the important part when you do this type of problem. Now the rest of it is just solving for these constants that would satisfy this condition. So if we, vector equation is going to give us 3 different equations, one for each component. So we'll have C1 plus 1 is equal to 1. That's where this first equation came from. C2 plus sine of 0, which is 0, is equal to 2. And that's where that second equation came from. And likewise, we would get the third. And we solve these 3 equations to get that C1 should be 0, C2 should be 2, and C3 should be minus 1. Should be why? Why? In order to satisfy the given condition that we must satisfy. So once we found how this constant vector looks, we just return back to the indefinite integral we got and use the specific constants that would allow us to satisfy that above condition. And here is the vector function that satisfies condition 1, which is telling us that the derivative better be this, which it is. Go ahead and take the derivative of this guy. You'll see et. The derivative of sine t plus 2 is just cosine. And the derivative of t squared minus 1 is just 2t. On the other hand, we need to make sure that at t equals 0, we get this vector. And you just plug in t equals 0 in here, and you'll see that indeed you would get 1, you would get 2 here, and you would get minus 1 there, which satisfies that condition.